1.5 functions and logarithms. What's a function? It's a relation. Relations are just pairs of numbers. And we've already talked about this. It's got unique outputs for every input. So we could have some random graph. And the best way to tell that it's unique is that we do the vertical line test and only hits once. All right, so if I come down and hit twice, it's not a function because I put in 10 and I get two different outputs. What's the point? I want a good model. That's how I describe a function. So it's a one-to-one function. It's a function with unique inputs for every output. And as I say, when are we going to need this? You're not. You're not going to need this. You will once in a blue moon. You don't have to worry about 1-1. Once, very rarely, you'll have to say, okay, hey, I can't work on this. It's not a function, but not on the AP test, just sometimes in mathematics. So this means it passes a horizontal line test. This is not a one-to-one function up above. All right, you can define it. Function is one-to-one, f of a never equals f of b whenever a does not equal b. All right, we make a function one-to-one by just limiting the domain. All right, what does that even mean? Who cares? We can say just, pick a certain spot. For example, let's just go from this spot here over. Sorry about that. Let's go from here over. All right, and then it passes horizontal and vertical. And we could do that, but back to the question, who cares? Well, I'm just going to keep it simple. We want a good model. Also known as a function. And we can do calculus on functions. All right. A good example of something you're going to get so deep inside the calculus, sometimes you'll forget it has to be a function. All right. So we're not going to worry about it. All right. Let's just make sure we know we have a function and then off we go. So that's it. Off we go. What's an inverse? Boy, oh boy, you're going to need this. Not the biggest thing you'll learn in calculus, but you need this. All right. An inverse is where I put an inverse, often defined with this funky little -1, inside a function, we get x. And if we graph, it's got symmetry across y equals x. You need to know this. Pops up often enough. You definitely need to know this. So how do we find it? Well, we'll throw out the f of x for a minute. Y equals -2x plus 4. And we just flip the x and y. And this is sloppy math. Right? Very sloppy math. Because we're going to change this y to an f of negative, an inverse function in a second. So this would be x minus 4 divided by -2 equals y. So we would say the inverse function is, let's just distribute this negative up because that's pretty hideous. Now let's just, negative x over 2 plus 2. That's an inverse function, right? Now, I was going to say we should graph it, but hey, look at that. My notes actually say down there. This is the same as f of g of x. I do not see this notation ever on the AP exam. I just want to make sure you're aware of it ever on the AP exam. So let's check it with graphing and then let's check it algebraically. We're going to need this y equals x line eventually. So negative 2x plus 4 is, I feel like that's wrong. And we'll find out. 1, 2, 3, 4. And down 2 over 1, 2, 3, 4. Connect the dots. F of x. And then 2, 1, 2, down 1 over 2. Connect these dots. By the way, when you do this in class, use your name tag. That's the way to do it. So those are actually reflected over the y equals x line. It's a horrible example to show that, but you'll just have to believe me. In the meantime, let's do f of f to the negative first of x. We get negative 2 times negative x over 2 plus 2 plus 4, which is x minus 4 plus 4, which is x. So we know we have an inverse. We'll check mark to make us feel better about our lives. Onwards. So you do it again. This time do it parametrically. No, I don't know what that means either, so thank God I have notes. F of x equals, let's do an arrow. X equals t, therefore y equals t squared. And t has to be greater than or equal to 0 due to this constraint here. The inverse of x would be flip the x and the y, x equals t squared. No, you will never have to do this. And y equals t, and t still has to be greater than or equal to 0. Sure, whatever you say. So we have y equals x squared. That's the original function. And when we flip it and solve, we get x equals square root of y. How do I know that? Because if I plug this in, I will get x square root of y. Squared is, I'll plug in x. Square root of y squared is y. Y is x. Y equals x. Yeah, whatever. Also, I was graphing this one parametrically. Whatever. Should yank this out of my notes. F to negative first of x equals square root of x. And graph this, you would get top half of parabola, sideways parabola, and bottom half. And you can actually see those are reflected. It's a little bit better. All right. What's the inverse of y equals ax? Well, a has to be greater than 0 because you can't have a negative base. That's why the limitations. And how would we do the inverse? Well, this is where logarithms come in. So we would have log, and we use a base of a. Because these cancel, we're left with x. So log a y equals x. That's our inverse. Remember, we do that little trick where we flip them and then we say the inverse, in other words. And we can prove this by graphing something to the x, assuming it's a positive exponent as that, and a logarithm as that. Here's one of the handier things I've learned in my life. This solves so many problems for me when I get confused. Hits at 0, 1, hits at 1, 0. So what's the domain and range of a logarithm? Hard to spell. Well, I just graphed it up there. So I'll do it again just because I'm so cool. Domain never hits 0, goes forever. Range, everything. It's an inverse function, so it's kind of the opposite of other things we've had. Oops, sorry about that. All right, now we got to go over logarithms. So write the inverse of y equals log 2 to the x. All right. So we use this little base to the outside equals inside. What I call BOI, taught to me by a student in 2007, I believe. And we say, well, then 2 to the y equals x. Base to the outside equals inside. Flip the x and y equals 2 to the x. These are inverses. On the opposite extreme, we're going to go with log base of 3. Log base of 3 of y equals log base of 3 of 3 to the x. They're going to cancel. We're going to get x equals log 3 of y, and we use that horrible notation. This really should say f to the negative first. Y equals log base 3 of x. These are inverses. All right. Now, what do we call y equals ln of x? Right, that's a natural log. I believe it's French log de la naturelle or something like that. I've never bothered looking it up, and I should. And that means it's a base e, which pops up in calculus. Otherwise, you're always like, why would we use base e? It seems kind of stupid. E is an interesting number. Why would we throw it in a base? Yeah, you'll see. It's the derivative of this is really cool. What about y log of 10? Well, this is a base 10 when it's not written. All right. Be aware of all this. We would never write this. We would just write this. All right, just be aware. It's coming, I'm warning you. So this always causes problems in my class. It's not hard to review, and I'm pretty poor at reviewing it because I always think, well, how hard can it be? We've done this a billion times before, but apparently a lot of people are, need the refresher, so it's fine. Solve for x, right? We want to get x out of there, we would do an e. I say we e it, which is really horrible math, but I like it, so the hell with it. X equals e to the 3t plus 5. That's it, right? If we need to get the x out, we need to get the 2x down, so we natural log both sides. Now notice this is, hey, we're done. 1/2 natural log of 10, which we could write as natural log of 10 to the 1/2, which we could write as natural log of square root of 10, which seems really weird. So let's prove that I'm not talking out of another orifice right here. So, and I won't lie to you, I really enjoy playing with logarithms because they're just so cool. I mean, just look at this. We got 0.5. And now let's do it the right way. Alpha y equals, give me a fraction. ln of 10, here's my ln, over 2. And I just proved that's the same as ln of root 10. No way, those are so different, it's impossible. Yeah, all right. So that's properties of logarithms. That's what we call a segue in the business, people. I think. I'm not really an expert. So here are some of your properties. I did not do any examples on these, and that's a really big problem. We're going to go right here. I'll come back to that in a second. We're going to get answers that are ln of x minus 5, and it's actually going to be in absolute values, but for now, we'll just leave it with that, minus ln of x minus 2. And it's multiple choice. When we look for it, we can't find it because it's not written like that. They simplify it with x minus 5 over x minus 2. So I usually just say, yeah, obviously, and I lose people all the time. Lose them all the time. I don't mean to. It's very upsetting. You might have the same thing over here. Log of x minus 5 plus log of, notice I changed it from log to ln. It would be ln, but that's okay. X minus 2. And the answer is written as log of x squared minus 7x plus 10. You're like, well, where did that come from? Well, they put them together, multiplied them, and then they distributed. Yeah, so be prepared. This one we just did. I will make an example where we have log of x squared. We write 2 log of x. And it might even be log of x plus log of x. Because 2 of them means they're being added together. And oh, well, that's, wait a minute, then that's x times x. Well, that's x squared. And round and round we go. So be prepared. That's not coming for a while, though. So a lot of people forget it from the beginning of the year to the later. Hopefully I'll review it, but I doubt it. So how about the change of base formula? Don't need it. We don't need it. But I'll show you where it comes from. So let's just say y equals log base 2 of x. And we want to, what in the world am I doing here? Yeah, so rewrite it. Base to the outside equals inside. 2 to the y equals x, and then take the natural log of both of these. At which point you're probably like, why would you do that? Well, I don't have log base 2 in my calculator. Yeah, you do. Yeah, you're right. I do. We'll graph them both, see if this works. But this is how you would do it, because I do have natural log very easily accessible in my calculator. So, okay, that means I can throw the y out front. And then y equals natural log of x over natural log of 2. So in other words, this graphs just like this. Prove it. I hear you screaming. All right, fine, take it easy. Sheesh. Let's see what we got here. We're still in parametric. Nice exercise to see if you remember how to get out. Second quit. Second quit. Y equals, boy, that's nice. Now notice we do have an actual change of base formula. Here he is on the newer calculators. So I want to log base 2 of x. And I also want to do, let's do a fraction. Natural log of x over ln of 2. All right, so that was a change of base formula. These should be the same. There's the blue one. The red one should map right on top of it. Very cool. So hey, we proved the change of base formula works. We're so smart. And I have a feeling I didn't share screen on that. Thought I did. Nope, didn't. And I'll show you what's going on. I'm gonna have to hit zoom 6. So sorry about that. Thought I shared the screen. So I put in log base of 2. Where'd that come from? Well, I did math up. There's my log base, so I can change the base here. 2 of x. And then I did a fraction bar and wrote this. So they should graph the same. So I'm going to hit zoom 6. Just going to refresh the graph. You'll see blue graph, and then you'll see red graph right on top of it. Sorry about that, everybody. Yeah, we're so cool. All right. So will we ever use that? No, never. Hey, it's nice to be educated. All right, Sarah invests $1,000 in account, 5.25% interest, compounded annually. How long will it take the account to get 2,500? I don't know why this is here. This is very upsetting. Oh, so I show you how to use natural log. Actually, this is a very good reason it's here. So 2,500 equals the initial amount, 1 plus 0.0525 to the t. Get the 1,000 out of there. So that gets you down to 2.5. And this is how I do this. I write that space in on purpose. Then we natural log both sides. Move the t down out front. T equals natural log of 2.5 over natural log of 1.0525. And we're going to round it horribly. I'm going to say it's like 17.9 years. All right, that's how we use natural log to get this thing down. And I believe I've done that before. So hopefully that gets you where you need to go. It's a pretty important lesson. Not as important as the next one. Brig's even bigger, but this is probably second place. Happy mathing.